two curves y equals to x squared and y equals to cube root of x intersect at points 0, 0 and 1, 1. Find the area between the two curves. Okay, so there are two curves, one at the top there, y equals to 103. At the bottom, y equals to x squared. Now, how to decide whether the curve is at the top or at the bottom? Now, if you look at this part, the blue line is at the top. Here, the green line is at the bottom. And here, the middle part here, green is at the top, blue is at the bottom. Then on the left-hand side, blue is at the top, green is at the bottom. So, which line is at the top? Which curve is at the bottom? Which curve is at the top? So you look at the shaded region. Where is the shaded region? This is the shaded region, right? This is the shaded region between the curve y equals to x squared and y equals to cube root of x. This is the region between y equals to x squared and y equals to cube root of x. Now, inside this shaded region, which curve is at the top? Which curve is at the bottom? Li Yin?
Yes, teacher.
Inside this shaded region here, which curve is at the top? Y equals to?
Y, green, the green color line.
This part. The green color one is at the top, right? What is the equation? The cube root of x. Who is at the bottom inside this region? The blue color. Blue color, what is the equation?
X equal to
X squared. X squared. So when I want to find the area between these two curves, it is no longer between the curve and the straight line. If it is between the curve and the straight line, we can use trapezium, we can use triangle, we can use rectangle to find if it's a straight line. But in this case, both lines are curved. They are not one curve and one straight line. So in order to find the area enclosed by these two curves, I use integration also, but I use the top curve minus the bottom curve. Because the top curve is bigger, is higher up, so the area is bigger. The bottom curve, the area is smaller. So I use the top minus the bottom. So it's very important for you to know which curve is at the top and which curve is at the bottom. And to decide which curve is at the top, which at the bottom, you have to look at the shaded region, not other outside the shaded region here. Oh, the blue is at the top, or here the green is at the bottom. Not outside the region. So it has to be inside the region here. So when it's inside the region, the green color is the top, the blue color is the bottom. So you use 1/3 x minus x squared. Chen Tong, your internet connection not very good. Always putus like that. Okay, right. Okay, now what happened? Okay, now we know very well what we are supposed to find, this area. And how to find this shaded area? You use the top curve minus the bottom curve. Now, what do you mean by top curve minus the bottom curve? It is like that. So the shaded area is integrate from 0 to 1. Why from 0 to 1? You see here from 0, the point of intersection of the curve here 0. The point of intersection of the curve here is 1. So it's between 0 and 1. Between 0 and 1. Okay. One more time. Maybe I show you here. This part is 0, right? This part is 1. So you see the 2 points of intersection, right? One is at 0, one is at 1. So I want to find the area between them. I integrate from 0 to 1. Okay. Integrate from 0 to 1, you use the top curve. This is the top. Then minus the bottom curve. This is the bottom one. X squared is the bottom one. X cube root of x is the top. So want to find area between them, use integration of the top curve minus integration of the bottom curve. Any question?
No, teacher.
No, no question. Okay, right. So we use the integration, the top integration minus the bottom integration, then integrate now, right? Integrate now. Okay, when you integrate, cannot integrate straight away. Why? Because cube root, I don't know how to integrate. So I change it to x to the power of 1/3. So I want to integrate x to the power 1/3. Then here integrate x squared. Next one. Integrate x to the power 1/3. That means you have to add 1 there. Add 1 becomes 4 over 3. 4 over 3. When it is 4 over 3, you have to divide by 4 over 3. Okay, then minus the second definite integral, x squared becomes x cubed divided by x to the power 3. So far, integration okay or not? Do you know how to integrate?
Understand, teacher.
Can. Okay.
Can.
Can. So now I'm going to substitute the numbers inside. Substitute numbers inside. 1. 1, oh, this 4 over 3, this 4 over 3 is at the bottom. So actually it's multiplied by 3 over 4, right? Multiply by 3 over 4. So 3 over 4 is something wrong, this one. 1 over 3 become 4 over 3. So I have to type this one, 4 over 3. Oh, cannot change. Why I put 2 over 3 there, I don't know. 3 over 2. Something wrong here. Something wrong. So I want to change the thing. Integration, then area and volume, area. Okay, you just hold on. I try to change. Okay, right. No, some more. Here. Okay, change to 4 over 3. 4 over 3. Okay. In screen. Paste. Yes, this one. Okay, come back here. Paste. Where did I paste it? Oh, here. Okay, so it's 4 over 3, not 1 over 3. Delete off this one. Okay, I put back here. Okay, so now when you substitute 1 inside, 1 to the power of 4 over 3 is still 1, right? Then when you substitute 0 inside, then you get 0. Over here, the 3 at the bottom, you can put outside and becomes 1 over 3. Then you substitute 1 inside, 1 cube is 1, right? Substitute 0 is 0. So what is the final answer?
Wait, teacher, I count.
The final answer is 5/12, right? 5/12.